Okay, in this video we're going to cover velocity versus time graphs, and we're going to get the following pieces of information from this graph. Instantaneous velocity, that is the velocity at any point in time, is plotted. Acceleration, from the velocity versus time graph, the slope gives us acceleration. And then we can get displacement from a velocity versus time graph, which is the area under the curve. So as a definition, which you should add to your notebook, the acceleration is the change in velocity over time. It is a vector, and if you want to see that in the equation form, acceleration is equal to change in velocity, delta V, over time. Again, change in velocity, that's going to be V final minus V initial. Okay. So we will answer 6 questions. Make sure you have space in your notebook. Question number 1, when is the object not moving? When is the velocity 0 meters per second? The object is not moving when the graph is on the x-axis. So here, at 0 seconds, the velocity is 0. And then at 8 seconds, the velocity is 0. So when the velocity is 0 meters per second, that is at 0 seconds and 8 seconds. Okay. When is the object moving at constant velocity? This is when the slope is horizontal. Slope is 0, I should say, or the graph is horizontal. This would imply no change in velocity, no acceleration, and that happens here between 2 and 4 seconds. Okay. When is the object slowing down? For a velocity versus time graph, the object slows down when the graph is going towards the x-axis. So when graph is approaching x-axis, or the horizontal axis. Okay, where is this happening? The graph, the object here is slowing down from 6 to 8 seconds. The object has some velocity, 4 meters per second at a time of 6 seconds. And then 2 seconds later, its velocity is 0. So this is slowing down. Only from 8 to 6 seconds. Okay, when is the object speeding up? Well, the object is speeding up when the graph is going away from the x-axis. So as the velocity goes away from 0 meters per second, where is this happening? If I look from 0 to 2 seconds, that is going from 0 meters per second up to positive 2, so this is speeding up. And then, of course, this is constant velocity here. So that's not speeding up or slowing down. The velocity from 4 to 6 seconds, hey, this is also speeding up. It's slowing down from 6 to 8 seconds. At 8 seconds, the object starts to speed up again. It's leaving the x-axis, speeding up in the negative direction. So that's what that means. When the velocity is negative, that means that the object is traveling in the negative direction, and because the graph is leaving the x-axis, that is speeding up. So several places here from 0 to 2 seconds, from 4 to 6 seconds, and from 8 to 10 seconds. These are positions, points of time where the graph is, where the object is speeding up. Okay, what is the acceleration of the object between 6 and 10 seconds? So from here to here, we will calculate the slope. So for this, we're going to need 2 data points. We need the xy coordinates for 6 seconds and for 10 seconds. So at 6 seconds, that's my x. So that's 6, 4. 6, 4, and 10, at 10 seconds, the object is traveling at -4. -4 meters per second. So we will, to get the acceleration, we take the slope. Acceleration is going to be y2 minus y1 over x2 minus x1. I guess I should say this is x1, y1. This is x2, y2. So we'll plug in our values. y2 is -4 minus y1 is 4. Divide by x2, which is 10, minus x1, which is 6. -4 minus 4, that's -8, over 10 minus 6 is 4. These were units of meters per second over seconds. That's going to be -2 meters per second squared. Meters per second, that's meters per second squared. That is the acceleration of the object between 6 and 10 seconds. Then we want the displacement of the object between 6 and 10 seconds, and this is where we will get the area under the curve. Under the curve, this is between x-axis and the graph. I'm going to make these 2 areas. The area that you will include from 6 to 8 seconds, this is area 1. And then from 8 to 10 seconds, and notice how I am trapping this area between the x-axis and the graph. Note our curves, quote unquote, they will be straight lines. This isn't a calculus-based physics course. We will calculate the 2 areas here and we will add them together. Please note, because displacement is a vector, we will have positives and we can have negatives for our areas. These 2 shapes, they are triangles. So to calculate the area of a triangle is 1/2 base times height. Our first triangle, this is from 6 to 8 seconds. It is going to be 1/2 times, it is a base, a base from 6 to 8. 8 minus 6, that is a base of 2 seconds. Times a height, all the way to the tippy top of the triangle, that is positive 4 meters per second. Note our seconds cancel. So the area, 1/2 times 2, that becomes 1 times 4 is 4 meters. Positive displacement. Then we'll get the area from 8 to 10 seconds. That's going to be 1/2 times a base. The base is from 8 to 10 seconds. That's a total of 2 seconds for the base. Times a height. Here we have a negative height. Go all the way to the bottom of this triangle. -4 meters per second is the quote-unquote height for this area. Times -4 meters per second. Seconds will cancel here as our units. This becomes an area of -4 meters. That's the displacement. So the displacement, we can then just add up these 2 values. 4 meters plus a -4 meters, 0 meters. the object comes right back to where it was. It comes right back to its starting position between 6 and 10 seconds. How does this happen? The object was being displaced in the positive direction, slows down, comes to a stop. Then the object starts traveling in the opposite direction and it's speeding up. So at 10 seconds, it's right back to where it came from at 6 seconds. So the total displacement here is 0. The distance, however, I leave this one for you. Distance, you don't care about positives and negatives. So the object has some distance. So what is the distance from 6 to 10 seconds? Thank you for watching this video and study well.